Okay. Now, the next step, we haven't written it, but we also saw it in this example on the board here. The next step was to say, what's missing, right? Wasn't that the question I asked? I said, what's missing over here? That's over here. What's missing over here? That's already over here. And all that matters is the denominator. It doesn't matter what's missing up top. So on the left-hand side, I've got a 3x and a 3x. What is not here that is on the right-hand side? X plus 1. So this is missing an x plus 1 in the top and bottom then. And remember, it's always missing in the top and bottom when you multiply, because you have to multiply by 1, which is a number over itself. On the right-hand side, what's missing? 3x. Now, my only word of advice is this. When you multiply, put parentheses around the things you're using if you're in down. Like this x plus 1, the 7 gets distributed to both terms, right? So it's important to recognize that this is in parentheses. Over here, not as much. X times 3x is just 3x squared. So that's pretty easy. But you will get to a point where you might have a binomial like x plus 1 here. The quantity x plus 1 times 3x, the 3x would have to be distributed, right? So think of your numerators and the things that you're multiplying by in the numerators as always inside parentheses. Is that clear what I'm saying? Okay, think about them as always as if they're inside parentheses. You don't have to show it every time, but make it a mental note for yourself. It will play a role when you have multiple terms, or multiple term expressions, i.e. binomials, trinomials, etc., polynomials. Monomials, not as much. The left side fraction, the numerator becomes 7x plus 7, and that occurs when I distribute the 7 to both. The right side becomes just 3x squared. Now that the denominator is the same for both fractions, I can write simply one denominator. And that denominator is x plus 1, 3x, 3x. And I'm going to leave it factored for now. Because if stuff's going to cancel with the numerator, I want it to cancel when it's factored, right? So I'm not going to multiply out my denominator. Write yourself a note. We are not ever multiplying out the denominator. Because we want it to be factored, so if we can factor the numerator now, maybe we can go ahead and cancel things, right? Can the numerator be factored? Is it possible to factor 3x squared plus 7x plus 7?
Well, you can factor out 7 out of the x plus 7.
But that'd be just doing what you had back here, wouldn't it, Alex? You can get back to 7 times x plus 1.
But then can you cross the...
No, because look, see the plus sign? Remember, you got all factors to cross off this x plus 1. It doesn't cross... If you cancel these x plus 1s, it defeats the purpose of what we did, right? I like what you're saying, though. Okay, it's got to be factored up top, so we got to be able to factor this if possible. Kevin?
Can you turn x squared into 3x times 3x and then cancel out the 3x's?
Same thing Alex just said. He asked, can we take out a 7 out of here and get x plus 1 and cancel that, right? Why would we do that? Wouldn't that be defeating the purpose of what we just did? And you can't do that because, again, plus sign. The only time you can cancel stuff is when they're, look, these can cancel, right? Because there's a time symbol. But there's a plus symbol here. Remember, this has to all be factored, and this has to all be factored to cancel factors. This is not factored up top. It's in standard form, 3x squared plus 7x plus 7. Can that be factored is my question. How do you know? What did you do? Good. Run it through your program. What did you get as roots? Were they imaginary or rational? Imaginary. So you can just run this through your program to see if it's factorable. If the answers you get from the program are rational, 1/2, 3/2, 2/3, 7, -4, -12, any of those rational numbers, then this can be factored if your program gives you rational roots. But if your program gives you irrational or imaginary roots, this cannot be factored. It's a good, quick check to see if it's factorable. Okay, you could also have done AC method to show. AC method will not work. If AC method doesn't work and you have a number in front of x squared, it means it's not factored. AC method will always work if it's factorable. Okay, so this one cannot be factored further, so it turns out that this is indeed our final answer. Okay, that is our final answer. We can rearrange it so it says 3x squared plus 7x plus 7, but there's no further step for this problem. Number 2. I'll give you 30 seconds. It's all you need. To factor the denominator. Sorry. Just to factor the denominator. 30 seconds. Go. And time. Should be done factoring at this point. That was not a hard factoring problem, right? We got to be speedy with our factoring when it comes down to it. Factoring will not go away. I keep saying it, right? AP Calc, Pre-Calc honors, even next year in Geometry honors, you will have some factoring in there. It's not going to go away ever. It's the fundamental nature of math is to break things into components, right? It's how you build things, building blocks. Factors are the building blocks. So what do we recognize though? What do we recognize right away? There's a good chance that in these problems, you'll have a repeated factor in both denominators. You see what I'm saying? To make them reasonable problems or make them problems that could be applied, there's a good chance you'll have a repeated factor. So, Alex, what's missing in the left fraction that's in the right fraction?
X minus 3.
I agree. X minus 3 is missing. So can I just do this? Is that reasonable? Should I do that or should I do something else? What did I say? I'm going to do that to start, but what should I do? To specify that I need to do something. I should do something. Francisco? Yeah. To recognize that the top needs to be FOILed, I should probably start doing my parentheses here because now I have binomials. Do you see what I'm saying? The top clearly has to be FOILed out. We're always going to multiply out our tops and then combine all like terms and then factor again. The bottoms we don't multiply out, so we can leave the bottom alone. Eduardo, the right fraction, what is it missing that's on the left fraction? Just the number 2. But I have to remember again that 2 is going to get distributed to the entire other numerator. So I'm going to put that numerator, negative 2x minus 1, in parentheses for that reason. Let's go check the time schedule. You guys have it in an email.
I think it's 17.
17?
Yes.
Okay. It's on a 7, I know that.
Yeah, it's awesome.
Okay, thank you guys. So the denominator is easy. We're done with that. There's literally no reason to simplify your denominator any further. The numerator takes a little bit of work. So go ahead and FOIL stuff out. The numerator, I'll do it as you do it as well if you want to check. And notice what I'm doing still. I'm making a huge point here. Look what I did. I'm subtracting the entire numerator, right? So I need a bracket or a set of parentheses around this after I distribute the 2. I distributed the 2 to get negative 4x minus 2, but I need to subtract that whole quantity from my trinomial in the beginning. So subtraction is defined as adding the opposite. So let's just make this, ready? Let's make this a plus sign. And then switch these signs both, make them both positive. I can always add the opposite. Okay, remember adding the opposite. More a question, or are you going to just tell me the next step?
No. I was wondering why you said it's separate, not just subtract.
Yeah, you could do it all in your head if you want to, okay? I'm just showing the steps. So I'm going to make this adding the opposite instead by putting plus signs down the middle there. So I've got x squared by itself. I've got a negative x right here. And a positive 4x, negative x plus 4x is 3x. And then at the end here, I've got a negative 6, and a positive 2 is negative 4. So I'm done, right? That's it?
I thought you canceled the x minus 1 if they're both. You cancel the x minus 1 because they're both.
Remember common denominators, things that are in both denominators carry over to your answer. So like here, the common denominator was 120, wasn't it? 2 to the third was in both, 5 is in both, 3 is in both, but we didn't cancel anything, right? We just carried over 120 and 120 as one denominator. Same thing here. These denominators are identical, aren't they? So we should carry them over. And we are definitely not canceling anything here with this because none of this is factored. But now I've got a quadratic. What can I do with this numerator? If a quadratic is there, what should I try and do with the quadratic whenever it's there? Factor it. Do you have the factors for me? Yeah, what do you got?
Negative 4 and negative 1.
So x plus 4, thank you, and x minus 1. And again, look for the repetition. Look for the factor that repeated. So now, Maura, if you're referring to this maybe, were you going ahead?
No.
Okay. So now, though, x minus 1 does cancel. You see that, right? Okay, so drop off the x minus 1s because everything is a multiplier at this point. We've got all things multiplying, so those will cancel. So here's my final answer. I might also see this on the SAT as a final answer like this. Just recognize that you don't have to distribute the 2, but you could. Right? You could. Not wrong. Either way is fine. I do not require you to multiply out your denominator at the end because it honestly is useless. It is useless. But the SAT might make a multiple choice where this is the answer on the right. Don't forget, obviously, that your denominator could be distributed to become this if you want. Can you simplify further? No. Because look, a plus sign here makes these addends or terms. A minus sign here makes these terms. Terms never cancel. Only factors, right? Got to know our vocab. I'm just prompting you guys. Okay, you got to know your vocab. That's 6. This will carry over to 5, 7. Let's jump right into that.